When you think of our solar system, you may think of Earth, Mars, Jupiter, or Saturn, all planets that orbit our star, the Sun. In the vastness of space, our solar system is just one star system of billions throughout our entire galaxy. It's hard to think of how small we really are, but we seem to forget that there is an object that outnumbers all of the planets. Those are the planets' moons. Europa is an icy moon that orbits the planet Jupiter. Sometimes referred to as Jupiter 2, it is the smallest of the 4 Galilean moons orbiting Jupiter, and the 6th closest to the planet of all the 80 known moons of Jupiter. It is also the 6th largest moon in the solar system, with just 1,900 miles of diameter. Europa was discovered in 1610 by Galileo. Europa was named after the Phoenician mother of King Minos and lover of Zeus, which is the Greek equivalent of the Roman god Jupiter.
Jupiter's large Galilean moons, Io, Ganymede, Callisto, and Europa, likely formed out of leftover material after Jupiter condensed from the initial cloud of gas and dust surrounding the Sun early in the history of our solar system. These moons are often called a mini-solar system, since they formed from the leftovers of Jupiter, similar to how Earth and other planets formed from the gas and dust left over from the formation of our Sun. The similarities don't end there. Each planet in the inner solar system is less dense than their inner neighbor. Mars is less dense than Earth, which is less dense than Venus, which is less dense than Mercury. The Galilean moons follow the same principle, being less dense the further they are from Jupiter. The reduced density at greater distances is likely due to temperature. Denser, rocky, and metal material condenses out first, close to Jupiter or the Sun, while lighter weight icy material only condenses out at larger distances when it's colder.
Europa's water ice surface is crisscrossed by long, linear fractures. Based on the small number of observable craters, the surface of this moon appears to be no more than 40 to 90 million years old. All along Europa's many fractures, and in the splotchy patterns across its surface, it is a reddish-brown material whose composition is not known for certain, but it likely contains salt and sulfur compounds that have been mixed with the water ice and modified by radiation. This surface composition may hold clues to the moon's potential as a habitable world. Europa is primarily made of silicate rock and has a water ice crust and probably an iron-nickel core. It has a very thin atmosphere composed primarily of oxygen. Cracks and streaks striate its surface, but craters are relatively few. Scientists are almost certain that hidden beneath the icy surface of Europa is a saltwater ocean, about twice as much water as Earth's global ocean.
Decades ago, science fiction offered a hypothetical scenario. What if alien life were thriving in an ocean beneath the icy surface of Jupiter's moon Europa? The notion pulled Europa out of obscurity and into the limelight, where it has remained, stoking the imaginations of people within and outside of the science community who fantasize about humans discovering life beyond Earth. And that fantasy may be grounded into reality. To find out for sure, NASA will launch the Europa Clipper in October of 2024. After a 6-year journey, the Clipper will reach Jupiter's orbit. The Europa Clipper will seek to confirm the presence of its ocean. For example, measurements of the amount of flexing due to the tides are an important indicator. If the ocean exists, the tide should deform the surface by about 100 feet. If the moon is frozen through, the tide should stretch the surface by only about 3 feet. Also, of great interest will be the composition of the reddish material on the surface. Scientists would like to know if this material holds clues to the composition of the ocean and whether the material is cycling through the surface and the interior. The Europa Clipper spacecraft will conduct a very detailed exploration of Europa to investigate whether the icy moon within its subsurface ocean has the capability to support life. Understanding Europa's habitability will help scientists better understand the potential for finding life beyond our planet. Liquid water tops the list of ingredients for life, and Europa has lots of it. Scientists think Europa has a salty ocean beneath its icy crust with about twice as much water to fill than all of Earth's oceans combined. Water dissolves nutrients for organisms to eat, transports important chemicals within living cells, supports metabolism, and allows those cells to get rid of waste. Scientists are confident there is a rocky seafloor at the bottom of Europa's ocean. Hypothermal activity could possibly support chemical nutrients that could support living organisms.
NASA's Europa Clipper will perform approximately 50 close flybys of the moon, gathering detailed measurements to investigate whether the moon could have conditions suitable for life. Europa Clipper is not a life detection mission. Its main science goal is to determine whether there are places below Europa's surface that could support life. Europa may be one of the most promising places in our solar system to find present-day environments suitable for some form of life beyond Earth. Do you think Galileo thought he may have found another celestial body with living organisms when he discovered it? With further research and exploration, do you think with the presence of an atmosphere and possible life, could Europa be reclassified as a dwarf planet? The future holds exciting possibilities. And you too can go outside at night with a pair of binoculars and see Europa with your own eyes. Until we meet again, be curious, be creative, and always look up.